What if I told you that the most fundamental experience we all share, that constant forward march of time, might not be real at all? What if the past, the present, and the future are all just a stubborn illusion cooked up by our minds? It sounds pretty out there, I know, but this is a question that's been bugging philosophers and physicists for centuries.
Okay, so let's jump right in with something that gets to the heart of our own experience. You've probably heard stories, or maybe you've even felt it yourself, in a moment of pure crisis, like a car crash. The world just seems to shift into slow motion. That feeling? It's a huge clue that our internal clock isn't nearly as reliable as we think it is.
And it's not just an accident. Have you ever glanced up at a clock with a second hand, and for just a split second, it seems frozen, stuck in place, before it starts ticking again? Well, that's a real thing. It's a well-known phenomenon called the stopped clock illusion, and it's just one of the many temporal tricks our brains love to play on us.
And this flexibility in how we perceive time is absolutely fascinating. Psychologists have found all sorts of weird distortions. For example, if you see an unexpected oddball image in a line of identical ones, your brain thinks it lasted longer. And in a scary situation, your brain goes into overdrive, creating way more memories. Later, when you play it all back in your head, the event feels like it's stretched out forever.
So here's the crucial point. If our own brains can't be trusted to give us an accurate report on the passage of time, it really begs a much, much deeper question. Is this just a weird quirk of our psychology, or is it pointing to some fundamental truth about the universe itself? This is where we have to move beyond the mind and start looking at the laws of reality.
And believe it or not, this is not a new debate. It's a philosophical battle that kicked off back in ancient Greece and is still raging today, just with some new modern vocabulary.
On one side, you had a guy named Heraclitus. He's the one who famously said you can never step in the same river twice. For him, reality was all about constant flow, change, and becoming. But on the other side, you had Parmenides, who argued that all change is just an illusion. He thought reality was this one timeless, eternal block.
In this ancient conflict, it's perfectly mirrored in the modern debate. What we call the A theory is basically our gut feeling. Time flows, the past is gone, the future isn't here yet, and only this very moment, the present, is truly real. But then there's the B theory. This is the radical idea, much closer to what Parmenides was saying. It argues that the flow of time is completely subjective, it's an illusion. The past, present, and future are just different locations in space-time, all existing with the exact same level of reality.
So let's really dig into this radical B theory a little bit more. Because if it's true, it means that the dinosaurs, the moment you were born, and the very end of the universe are all equally real. This whole concept is often called the block universe.
So under B theory, which is also called eternalism, there's absolutely nothing special about now. Your experience of this present moment is no more real than your memory of what you had for breakfast yesterday or your excitement about a vacation next year. It's a really profound shift in perspective.
A really great way to visualize this is to imagine the entire history and future of the universe as a giant stack of photographs, okay? Each photo is a single moment, a single now. Our consciousness is just us moving through the stack, looking at one photo at a time, which creates the feeling of flow. But for B theory, the entire stack, the whole block universe, already exists, all at once.
Now this might all sound like really abstract philosophy, right? But here's where it gets truly mind-bending. Our most fundamental theories of physics actually seem to agree with the philosophers who say time isn't real.
See, physics has a huge problem. Our two cornerstone theories treat time in completely incompatible ways. On one hand, you have quantum mechanics, which runs the world of the very small. It needs a rigid universal clock ticking away in the background. But then you have Einstein's general relativity, which governs the very large, and it tells us time is relative. It can stretch and shrink depending on gravity and how fast you're moving. It's literally woven into the fabric of space-time.
And this is what's called the problem of time. When physicists try to write a single equation to unify these two worldviews, something completely astonishing happens. The variable for time, the letter t, it just cancels out. It disappears from the math. In our most fundamental description of reality, there is no time.
Physicist Julian Barber is a leading voice for this timeless view. He argues that what we perceive as the flow of time is actually just our interpretation of static time capsules. Think about it, a fossil, a photograph, or even a memory in your brain. These are all fixed patterns that exist right now, in the present, but they contain information about what we call the past.
But hold on, this idea of a timeless universe is far from a done deal.
Plenty of physicists and philosophers are pushing back hard, saying that to deny time is to deny our most direct and fundamental experience of reality itself. Physicist Lee Smolin is a really prominent critic of this whole idea. He argues that physicists like Barber have made a classic mistake. They're confusing the map for the territory. Just because time vanishes from their equations doesn't mean it vanishes from reality. For Smolin, time is not only real, it's fundamental, maybe the only thing that's truly real.
And there are some strong philosophical arguments too. Arthur Pryor offered this simple but incredibly powerful thought experiment. When you say, "Thank goodness that's over," after a really bad headache, what are you actually thankful for? B theory says you're just thankful that the headache exists at a different coordinate in space-time. But that just doesn't capture the deep, genuine relief we feel, does it? That relief really seems to require that the pain is truly gone, that the past is no longer real.
You know, there's a middle ground here, too. The physicist Carlo Rovelli suggests that while time might not be fundamental, our sense of its flow, what we call the arrow of time, is a very real phenomenon. He thinks it emerges from the second law of thermodynamics. The reason we experience time flowing from past to future is the same reason a hot cup of coffee always cools down and never just spontaneously heats itself up. It's all about the universe moving from a state of order to disorder.
So, after this whole journey through psychology, philosophy, and physics, where does this leave us? Is the steady ground of the present moment we're standing on actually solid, or is it just a phantom?
Okay, let's just recap the big conflict here. First, we know our own brains are totally unreliable when it comes to time. Second, philosophers are completely split between time being a flowing river or a frozen lake. And third, our best physics seems to point toward a timeless reality, even though that conclusion feels deeply wrong to our everyday experience, and plenty of brilliant minds are pushing back against it.
You know, maybe the best way to think about it comes from Carlo Rovelli again. For thousands of years, our direct experience told us the Earth was flat. It took science to show us the deeper, curved reality. Well, in the same way, our direct experience tells us that time flows, but the deeper reality of the universe might be something else entirely.
And so I'll leave you with this final thought. If the B theory is correct, if the block universe is real, it means that every single moment of your life, your first step, your greatest triumph, your final breath, all of it exists eternally, just written into the fabric of space-time. Your story isn't unfolding, it's already complete. What you make of that, well, that's the biggest question of all.